So now let's go to move to the insemination program. Okay, as far as you know, we have a fertility window. This fertility window is considered the time when you have to inseminate an animal to high sure that this particular sow is going to be pregnant. You can find many studies in the bibliography to try to see what are the best hours for inseminate an animal, but in the most of the cases, in all of them, this fertility window is 24 hours prior to the ovulation and no more than 4 hours after the ovulation. And in general terms, our target is inseminate our animals prior to the ovulation. So we have around 24 hours to do, with respect to the estrus, to do a good insemination. And the point here is how many hours last an estrus. And the last of the estrus, depending on most of, I am sure that you are thinking in the animals, but it's not, depending on the people who is checking the estrus. And these guys has a very important impact in the program that you have to use in your farms for the insemination. And now we are going to see what I'm telling about. Here you are a couple of examples of 2 farms in Spain with a very good results in all of terms. They are more or less, they have a 95% of fertility after the insemination. Very good results, both of them. Let's go to see how Julio is the farmer, is doing the heat checking. He used a TC board in front of the animal, and as you can see, Julio is an observator. He observed the behavior of the animal, but he don't participate actively in this process. He only observed. But the situation is completely different in the second farm. In this farm, René is using 3 or 4 different TC boards in front of the animals, and in the first moment he touched the animals a lot. He participated a lot in the stimulation of the sow. These 2 ways in how to heat detection determine how the ideal program have to be, and I'm going to tell you why. Here you are, all the follicular phase, a complete follicular phase. This is the different phases of the ovary during the estrus. These first couple of them are in the proestrus, just before to the standing. These another 3 ones are the estrus. The estrus is the phase where the animal present as the standing, and here this is the moment of the ovulation. You can see, perhaps you can see here these points, red points. This is the point where the egg go out, and this is the meta-estrus. Here the ovulate has happened, and we have here the corpora hemorrhagica. Corpora hemorrhagica, the evolution of this is the first corpora lutea, and later of this we have a diestrus phase with a corpora lutea and a progesterone. Okay, but these ovaries, all of them are in the follicular phase. Some point about the physiological issues here in this part. As you can see, the follicular phase, the mainly characteristic is how growth the follicles began when the psoas and estrus, they began around 4.5 millimeters, and they are growing and growing up to 7.5, 8 millimeters more or less, and just in that moment they change the shape more polygonal, and after of this the ovulation happened. The ovulation is a very quickly, very fast process that only happens in 3 hours. Remember the observator farmer? When the observator farmer detects the estrus, the size of the follicles are bigger because he only observed the animals, and the duration of the estrus for this kind of farmers are shorter in general terms. Completely different is the situation of René. The people who stimulate is usually that anticipate a little bit the estrus, and when he detects the estrus, the size of the follicles are smaller, and as where the growing of the follicles is constant in the time, the duration of the estrus in these cases are longer. So imagine that we have imagine that we have a sow with that sow an estrus in day 4 after the weaning, and in our protocol we have that we are going to inseminate the first insemination just in the moment of the detection and every 24 hours. That is a very popular program of insemination. What happened with the insemination of Julio? As you can see, the first insemination is just in this fertility window. Remember, 24 hours prior to the ovulation, no more than 4 hours after the ovulation. The second insemination, some of the animals is going to be good and some of them is going to be no good. And the third insemination is too late because of is more than 4 hours after the ovulation. The eggs are just fecunded in that moment. And what happened with René? That the first insemination, how the heat detection is soon, the first insemination is 40 hours before to the ovulation. All the spermatozoa died during this process, so this insemination doesn't work. The second insemination is good, very good, because it's around 12 hours prior to the ovulation, and the first insemination is in the most of the cases after the ovulation, more than 4 hours after the ovulation, and again the eggs are just fecunded or the eggs are died because the life of the eggs is around 8 hours, something like that. So in this particular case we use 3 inseminations, but only 1 is useful. So in the farms how we can see this, we can to evaluate how the people are heat detection, and we use ultrasound to do the animal transparent, and in that case we can see the ovary and all the process of this follicular dynamic. So we can check when they are inseminate our sows with respect to the size of the follicle with respect to the ovary. In this particular example, I talk with Julio and I say, okay, your third insemination doesn't work, you can remove. The first insemination you can wait a little bit, and you have to put your second insemination a little bit sooner. For instance, you can wait 8 hours from the heat detection, and you can wait 16 hours for the second insemination. And with René, I tell him that the first insemination doesn't work because it's too soon, and the third insemination we can move a little bit and with respect to the first one. So if you see, all of the insemination are in the same moment with respect to the ovary, but not in the same moment with respect to the heat detection. So I can understand that it's not easy to do these studies of follicular dynamic because of it requires technique, it requires good matching. I understand that, but we can do many things in the farms in terms of at least try to analyze the heat of the duration of the heat, try to analyze how the people are doing this heat detection. And if we know the heat of the duration, we can understand more or less how we are using our insemination with respect to the ovulation. Why you can do that? You have to measure only the duration of the estrus and consider that the ovulation happens in the 68% of the duration of this estrus. For instance, if the duration of the estrus is 50 hours, the ovulation in the most of the cases is going to happen in the hour 33. So you can compare when you are using your insemination with respect with this hour, like this. In this case, we are checked 7 different farms in a big company in Spain with 25,000 animals, and they are using the same program for the 7 farms. And as you can see, the inseminations with respect to the ovulations sometimes doesn't work. For instance, in this farm too, this first insemination is too soon, and in all of the cases, the third insemination that they are using are too late. And what happens this? Because of, look at that, 7 farms, all of the same company, all with the same genetics, all the same food, everything equal, but the duration of the estrus is very different between the farms. And the reason of that is because of the people, because of the sensibility of the people. And we have to see this sensibility of the people. This is very, very important to work with the people, stay close to them. In this particular company, 24% of the doses that they are using are out of this fertility window. They are not fecundants. This is many money in terms of boards, in terms of doses. So we in terms at the end in terms of efficacy. So as happens with the gills before, it's very important to analyze the particular situation of this farm, because of the things can change between the farms a lot. Another important point that I have to consider here is the nutrition. I said at the beginning of the lecture, I said how important it is to give to our animals a good nutrition. And this is the curve that we are using during the gestation. This is the typical curve that we are using in Spain. Basically, we use high levels of food just at the moment of the wean, to try to recover a little bit the body condition and to try to give to the animal all the best for this follicular phase. And during these first 30 days, that is the days of the embryonic phase, it's very important to maintain high levels of feed, because we need this level of feed for the placentation and for the production of LH. That is very, very important, this production of LH, to maintain the corporal lutea to produce progesterone. So it's very important to maintain this high level of feed during first days. Only one exception sometimes happens with the gills, that we have to use low levels because of the clearance of the progesterone. The meaning of that is that if you use high levels in the gills, in some cases, we induce that the liver is going to work more and more, and this work of the liver induce the clearance of the progesterone, and we don't have a good levels of progesterone in the blood, and this is one of the reasons of lose the gestation. So this is only well demonstrated in gills, and we can work with these low levels during the first week after the insemination, but it's not necessary in sows. Remember, if you want to have a good weight at the moment of the birth, it's very important the placentation, it's very important to maintain high levels of food the first 30 days. In the middle of the gestation, usually we use a low levels for economically reasons. Only you have to maintain the body condition in the animals, no more. And just at the end of the gestation, usually we increase again, no more, not a lot, but we increase a little bit to give vitality to the piglets. No weight. Weight is at the beginning of the gestation. At the end of the gestation is give them some vitality and up to try to maintain the body condition of the sow also. So it's for us very, very important that farmers knows how many kilograms of feed have to do per sow per day during the gestation. Consider that we have to weight the feed from time to time, because sometimes the volume with the same volume of feed we have different weights. Remember that the body condition, we are going to lose the body condition very quickly, very, very quickly. In 10 days we lose the body condition, and it's very, very important to maintain a good body condition during the gestation. But the things don't begin in the gestation, the things begin before, during the lactation. Just after 10 days after the farrow, the follicles begin to grow, and these follicles is going to be the follicles who are present during the next estrus. So the nutrition during the lactation have a very high impact in the next cycle. So for instance, in this couple of sows, this is a farm who have electronic control feeders during the lactations, and as you can see, the line, the blue line is the feed that the sows are eating every day, and you can see here that in this first sows, he are always in the target. The target is the green. In the second sow is completely different. The sow is not eating properly, and the consequence of this is the quality of the ovary. These ovary are taken by ultrasound just in the moment of the weaning, and as you can see here, this ovary with a different follicles, all of them more or less with the same size, around the 4 millimeters. This is the best situation in the wean. But in this second case, we have different follicles with different sizes between 2.7 to 4, and this is more heterogeneous, and this ovary is not well prepared. Sometimes we are using vaccines in this period of time, around day 10, for instance, with parvovirus aerosopilotes is very typical to vaccinating, at least in Spain. And it's important to have a vaccine that not induce fever because of these reasons. If the animal has fever, is not fit, the animal is not going to feed properly, and we are going to have this kind of problems at the weaning. So finally, we are going to check some clinical cases in relation with reproduction failure, in that case in relation with infections. The first clinical case appears in a farm when we began to see that we have returns to estrus, especially in gilts. As you can see here, 53% of our returns are in gilts. This is our graph that we use to try to analyze the rebreedings, and there are different parts in the graph. The first part is the number of total rebreedings that we have. In that case is 26%. And these and other bars mean how of these animals who are rebreedings go finally hence in a farrow or are sent to the slaughterhouse. In this particular case, as you can see, 80% of our rebreedings go to the slaughterhouse. And by the other hand, we have the same proportion more or less between the cyclic rebreedings and acyclic rebreedings. So the meaning of that is that we are lose the embryos more than between the third and fourth week. When that animals goes to the farrowings, we can see that the total mummifies are increased a lot, as you can see here in the results. So our target in particular is that no more than 50% of our farrowings have to have at least one mummies, and no more than 2% of them in every single litter. Another point that is important to consider in this particular case is that 37% of our gilts had less than 10 piglets. So look, these symptoms and the analysis after in the lab tell us that we have problems with parvovirus. But nowadays, one of the things that we can do in the farm is to check the embryos, but because of, if we have this situation in the farm, we can suspect that we are losing the embryos. This is one direction of the diagnosis, or the second direction is that we have problems with the fecundation with our insemination program. And what are the things that we can do in the farm is to check the animals by ultrasound. When we do the ultrasound for recognize the pregnation of the animals, we can count the vesicles. You had seen an uterus plenty of vesicles, more than 14, in compared with this another one that, as you are going to see now, this area is without any vesicle. So clearly there is a big difference between these two animals. So I usually split the animals in 4 categories: less than 8, 9, between 9 and 10, between 9 and 12, 13, 15, or more than 16. Obviously, it's impossible to see exactly the number of vesicles, but you can put it's easy to put the animals in one of these categories. And in this particular case, in the first case, we have more or less the same results in the echo that in the farrowing. In a longitudinal or transversal study is the same. But here we don't have any problem with the embryos loosen. But in the second case, clearly the results are different between the echo and the farrowing. So we are clearly loose embryos here. And here we will have the results between, in this particular case, we have a stressful situation after the crates in these pens. In this particular facility, the temperature is under control, and in summer we have a higher temperature, and this is the reason due to we lose the embryos in these pens. And what we do in this farm is compare the results in the same batch using the pens or leaving the animals in crates. We count the vesicles 10 days after to put the animals in pens, and as you can see here, we have less piglets just in that moment, and we confirm this diagnosis later with the total borns in the same batch during the farrowing. So as you can see, it's very difficult to count exactly the number of vesicles, and usually you are subestimate the number of piglets, but the results or the diagnosis is going to be the same. So it put us, it showed us how important it is to maintain the good protocols in terms of, in this case, parvovirus. In general, it's very important to maintain the protocols that the labs recommend, but for every single vaccines. But in case of parvovirus, is very, very important. Very quickly, the second case is a case where we appear of 5 abortions. We had 5 abortions, and in this particular case in the south, we had 3 from 5 animals with fever. And in that case, this is a case of erysipelotrix, we didn't see any skin lesions. It's very, very frequently that you can see, but sometimes don't happen. And I would like to show you this slide because this is the way that I use to analyze the reproductive failure in relation with the rebreedings in a farm. Usually, I consider that there is 4 different kinds of animals in the farm. And in general terms, if you have problems with the rebreedings, my particular opinion is that you have to analyze in one way the gills, the wing animals, and the animals who comes from an insemination, abortion, or other reproductive failure. And I split the wing animals in primiparous that are totally different than the sows, and the multiparous animals. So I split all my population in these 4 groups. And then I analyze how are the characteristics of the returns, with a couple of important points. If the returns give me a farrow or not, this is important, and the characteristics of the returns in terms of cyclicity. And again, the graph that you see that we have seen before, this is the situation prior to the case, and the things change completely with the case. Begin to appear more rebreedings, and in that case we have cyclic and acyclic rebreedings again almost in the same proportion. Sometimes in this particular case we are going to see how increase the rebreedings with a lot of days. This is very typical, and sometimes happens that the animal dies inside, and we are going to have more stillbirths. How to differentiate by ultrasound if a fetus is alive or not is not very difficult. Basically, we are going to see how the animal is moving inside, or the head is beating, and here you can see this circle, black circle. This is the stomach with the meconio. Sometimes, if you have the possibility, you can see the vessels with the blood inside of them. On the contrary, if the animal is dead, there is not any liquid amniotic, the animal is not moving, and the heart is not beating, and it sometimes appears like a mass inside of the uterus, giving us problems of endometritis. So this is all the things that I want to show you today. As you can see, it's a general review, but point the focus in some technical of diagnosis, especially in puberty, and how to analyze our ideal program. Thank you very much, Bruce, and thank you very much all the audience.
그래서 오늘 이렇게 긴 시간 동안 경청해 주셔서 감사드리고요. 오늘 말씀드렸던 초음파를 이용한 성성숙 판단, 그리고 이제 그것을 이용한 교배 적기를 잡는 방법, 이런 것들이 농장에 많은 도움이 됐으면 좋겠습니다. 경청해 주셔서 감사합니다.